Next up, we have Dr. Jansson, James, with his presentation on XCredits, high-capacity blockchain platform, the financial backbone of the future. Sounds impressive, and I'm looking forward to finding out more.
Excellent. Yep. Thank you for having me tonight. XCredits is a pretty young project. We started earlier in 2018. I'm going to go through some of my motivations, some technical aspects of how our system works, and then an outline of what we plan to do with the company later on. So, this is the big problem. There are 1.7 billion adults who don't have a bank account. Those people have a hard time transacting with one another, and that restricts their ability to get themselves out of poverty. In addition to that, it's not just the third world that has problems with their financial infrastructure. If you've ever tried to get information out of your bank, like an old transaction list, or you wanted to link your data from your bank to your accountant, it's a very manual and old school type of process. And by moving to a system where you're doing open transactions, you might be able to actually improve people's financial independence and the ability to do things like shop around. So I think that the current financial system is quite outdated and restrictive at the moment. So on to our mission. We want to bank the unbanked and make transactions open and efficient. And so we're building a high capacity blockchain for the backbone of the financial backbone of the future. It's going to be highly scalable, low fee, and permissionless. So these are the core challenges that I see with blockchain at the moment. It still applies. So firstly, we have the issue of scalability. There are no blockchains in common usage right now that can achieve permissionless at-scale transactions. And if we don't have enough capacity in the system for people to use it every day, blockchains will never be accepted in mainstream usage. Another issue is privacy and compliance. It's actually very hard for financial institutions to do things like put customer data on the blockchain if that data is open and accessible to everyone. So a lot of people talk about Zcash and Monero these are the evil coins that are private and the banks will never accept it, but I actually think it's the opposite. I actually think that Bitcoin is too open and would prevent the banks from being able to put transaction data onto the blockchain in that format. Because if they put a customer transaction in there and it gives information about what they bought and who they bought it from, they're violating privacy law. There are other compliance issues like KYC and anti-money laundering. And then the final one, and I think this is underrated in the general sphere of cryptocurrency, integration. The user experience is pretty shoddy. The apps are getting better, but it's actually still pretty hard to get crypto. And I think that it needs to be really, really straightforward to someone say, I want to start accepting a crypto-based payment, and it should be a 5-minute setup process and away you go. So on to the first problem there, scalability. If we look at the transaction capacity of a few major well-known systems, you have NASDAQ at 10,000, MasterCard at 38,000, Visa at 56,000 transactions per second. Then you have Bitcoin at 3 and Ethereum at around about 20. These systems don't have enough capacity to handle our credit cards, let alone all the other transactions that we do. Imagine trying to get everyone through the turnstiles with your Opal card using Bitcoin if you can only get 3 people out the door per second for the entire world. We need more capacity. Now, there are solutions on the horizon, but it's my strong belief that there's still not enough transaction capacity on things like Lightning and Raiden. And just to explain a little bit about what that is and why that is exciting, but also why there's, I think, too much hype around that. Imagine you've got 2 people and they're looking at the blockchain. They both have Bitcoin, for example. They decide that they want to do lots of transactions between each other. And so they put a little note onto the blockchain that says, we're going to open a transaction channel between us. We're putting in half a Bitcoin each, and in a little while, we'll work out what the balance is. In the meantime, they do lots of transactions between each other. And while they're doing that, they're numbering those transactions and they're saying they're both signing this transaction. So at the end of it, they'll have the ability to go back to the blockchain with that information and claim the Bitcoin that they're owed. So at the end of it, they decide, yep, we'll put a transaction onto the blockchain and we'll be square at the end. The problem comes when people try to cheat. So you do have a timeout that allows you to, if one participant tries to put one of the earlier transactions in, tries to put that one in instead of the next one, one of the participants can come back and say, actually, they said that there were 5 transactions, there's actually 6, please put that one in. The problem with that is that in order to prevent cheating, you need to have affordable on-chain transactions. And if you have so few transactions, they're not going to be affordable. At the end of 2017, Bitcoin was $50 per transaction if you wanted to get a transaction on the blockchain in a hurry. And if someone's trying to cheat you out of your money, you want to do that. So if someone's tried to cheat you out of, say, $20 and the transaction fee to claim it back is $50, it's actually economically not worth your while to try and claim it back. So if the transaction fees are too high on chain, Lightning won't save you. And just to give you a context of how bad the situation is with Bitcoin, if you wanted to get people onto the Lightning network and then do one transaction, one closing transaction, Bitcoin does 3 transactions per second. There's 7.5 billion people in the world. That means that you can do 1 transaction per person every 80 years. And if you want to do 2, it's 160. So there's nowhere near enough on-chain capacity in order to open affordable Lightning channels on the Bitcoin network. And it gets worse because there's more people being born per second than there are Bitcoin transactions, so they can never catch up. So the conclusion is that Lightning and Raiden is useful. We don't need all the transactions on the blockchain, but if that's the only scaling solution, we're going to fail. So we need more on-chain scaling solutions. So that's where XCredits come in. It's a sharded proof-of-work blockchain. And I'll just explain roughly how that works. In our system, our blockchain acts like multiple blockchains working together. You have multiple shards that track transactions and communicate with each other. So in this case, we've got shard 1 and shard 2. The state from one is passed down, one block is passed down to the other in a normal blockchain like you'd see in Bitcoin, for example. There's an extra feature. I'll go into a little bit of depth with this later on. You can shard your fork. Fork your shard, where you might have lots of miners that are competing all at once and producing lots and lots of blocks. Usually they get thrown away. In our system, we can reuse them, but I'll go into that in a little bit more detail later on. Importantly, you have a central chain, and that central chain is keeping track of the state of the side shards. It's not keeping track of all the transactions on the side shards. It's just showing where the side shards are up to. What you have is the state of those side shards being pushed into the central chain, and then the state of the central chain pushed out to the side shards. So I've shown how that builds up. Obviously, it doesn't like start from shards and then go to the central chain. What actually happens is you get a couple of blocks being transacted on the side shard. The result gets pushed to the central chain. It gets pushed back and forth. It's like edging forward. All of the blockchains edging forward together, all in unison. We are a proof-of-work system. The way that we break up the work is 50% goes to the central chain and 50% is split between the side shards. So I will explain how we incentivize people to get into the side shards and maintain the network. So imagine you've got this is one of the side shards here, and here's the central chain. Someone's just mined a block here. The R here represents the reward pot. So this is how much rewards are currently in that side shard. Someone's mined that, they get a fee. In this case, we're showing 10% of the fee going to this miner per block. It will probably be closer to 1% though, it wouldn't be that high. But just to make it clear how much fee is going to each individual, this miner gets 573 of the XCredits. Then someone pushes the central chain result to the side shard. Then the reward pot gets topped up by 1,000 XCredits, and now the fee to the miner for mining this block is 619. Once again, where the reward pot is down to 5,576, 10% goes to the miner. Another central chain block is mined, and you push that result in. So you're constantly topping up the side shard reward pot with the central chain. So this is incentivizing the side shards to keep on pulling in that central chain block result. Now on the other side of things, we have a minimum amount of proof of work that's necessary per side shard in order to mine a central chain block. So you have to get enough proof of work between this central chain block and this central chain block on that side shard and all the other side shards in order to mine that central chain block. If you don't have enough proof of work, you have to wait until that side shard has been mined. So in that way, you have an economic incentive to spread out all of the proof of work and all of the validation between miners in the system. Another innovation that we have listed in our in the presentation blurb for tonight is microblocks. So in Bitcoin, you might know there's a roughly fixed proof of work. Obviously, this varies as the amount of servers come online or not, but there's a fixed amount of proof of work and there's a fixed block size. It has to be at most 1 megabyte. So that's to limit too much transaction spam on the network and keep it sustainable. With XCredits, we do it a little bit differently. What we do is, instead we say, you have to do proof of work, but on a per byte basis. So we're keeping track of the number of bytes that end up on the blockchain. If you've got 10 kilobytes instead of 1 megabyte, you can start mining that straight away, and you can get 10 kilobytes worth of reward. If you have twice as much kilobytes that you want to put onto the blockchain, you have to do twice as much proof of work, but then you also get twice as much reward, which is that bit there. There are side effects, some which are good and some which are bad. So it's actually better for home miners. So if you've ever tried to look at mining on the Bitcoin blockchain, the blocks are worth, I don't know what it is exactly right now, but it's like $80,000 a block. So if you wanted to have a pretty high certainty that you wanted to get a block in a day, you might have to spend $80,000 worth of electricity on a block. And that's a lot of money. If you've got these micro blocks on these sharded blockchain, you might be able to generate a few dollars worth of mining reward per day on your home computer, and you will actually get the opportunity to receive that reward. So it's better for home miners in some way because there's more regular payoffs. The other side effect is that it's likely that the miners will push towards making smaller and smaller blocks. So if you have variable sized blocks and you can make the smallest one possible, it's actually better for you from a game theory perspective. Mine a block, get it out there, and then let people mine after you. You get your block validated more quickly. So those blocks could get very, very small, which also has this negative side effect in some ways of causing forking. So you see a block being mined, one person decides to jump in and is mining a new transaction over here, and another one is mining a different transaction over there. Those two miners are providing validation power to the network, but under normal blockchain, one of those will eventually be rejected. Now, the mining system can pick up those transactions, but all of that proof of work that other miner dropped in has been wasted. So we've developed a system where you can actually recover some of that, and it's called fork merge mining. So the idea is, let's say you've got a block here and it's got a couple of transactions in the block. This block is being transmitted to the network. So everyone's heard about it. Then this miner starts mining on this block, and then another miner is also mining off B0 in this case. So we have a situation where you have two blocks, they're both downstream from this main block. So we have to work out how we can put it back together again. After a while, we have a few more blocks. You'll notice that all of the transactions in these blocks, they're separate. So what we can actually do is we can merge in these blocks. We take in transactions, blocks B, B prime 1 and B prime 2, and we put it into block 4, and we put it before any of the transactions in block 4. Because there's no overlapping transactions and no contradictory transactions, there's no double spends in either of those blocks, we can successfully merge them in. So now what we've got is all of the proof of work for B1 and B2 actually adding more power to B0 while we're on block 4. So it's actually saving a lot of hashing power.
Question now, what if you have a conflict of transactions?
So we've got conflicts. Yes. So imagine you've got a situation where you've got two transactions here, TX8 and TX8. They're on separate chains, separate forks of the same chain. You're not allowed to have both of those transactions being merged in because it's like you've got a double reference to that transaction. So what you do then is, and the reason why we don't allow that to happen is because it actually makes it very easy for someone to try and censor transactions and rewrite the blockchain if you don't force people to keep on merging in a consistent way, like you might be able to keep on censoring particular transactions. So it always has to be consistent, no double transactions. But what we can do instead of trying to merge it in there is we can resolve it by pulling in the blocks that aren't conflicting and then reusing, in this case, transaction 9 in B4. So in this way, we have a successful merge of those two forks of the same chain. Now there's...
How did you determine the bottom TX8 as the one to accept?
So the reason why we accepted the bottom one is because it's the longest. So it has, like, I haven't really demonstrated it very well, but it has more transactions. It means it has more proof of work. So you're going to accept this bottom chain. You aren't, in our system, you're not allowed to merge a longer chain into a shorter chain. But you could choose an organization where you take B0, B1, and then B1 prime and B2 prime and ignore B2, B3, B4. But obviously that's not going to be in your best interest because you're going to have a shorter chain than the other miners who see which one's the obviously longer one. So in general, the miners should behave correctly if they're economically sound. There is a risk in a fork merge mining situation where, let's say you've got lots and lots of forks that are going on and you want to create a new transaction. You really need it to happen now and you don't want it to be disregarded. In this case, transaction 7 in B3 could be disregarded because the network can see TX8 and TX8 in B prime and B2 normal. What you can do instead is you can actively choose to mine your blocks. If you really want transaction 7 to not be lost here, and you're, let's say, on a latent connection, there's a lot of delay between you and the other network participants, you can actually decide to mine downstream from an older block and wait for other miners to pick you up. So you're basically, you're waiting for them to pick you up. And the reason why they're going to pick you up is because those miners get a fraction of your block reward when you get merged in. So it's not cost-free. You have to give away some of your block reward, but by providing that block reward up front, you have a stronger economic incentive to have your block merged in. Next thing I'm going to talk about is our ASIC-resistant block hard mining system. It's kind of an interesting way to do things, but before I jump too deep into our system, I'm going to run you through how Bitcoin basically works. So down here we have a block, and the block has the data about the transactions that are about to go into the current block. So you have transaction 1, transaction 2, transaction 3, and transaction 4. This data is then hashed into a Merkle tree. And to give you a very brief overview of what a Merkle tree is, you take the data of all of these transactions and then you hash that data. And that creates it's quite a bit shorter than a transaction, but it's still quite long, has a lot of entropy, has a lot of randomness to it. So they're random strings, hard to cheat to create a new version of that hash. So you hash the transaction, and then you take the hashes of the hashes, and then you merge them into another hash. And then you take the hashes of those hashes, and you merge it into another hash, which is called a Merkle root. And the good thing about this Merkle tree is that in order to prove that transaction 3 is in the blockchain, I don't need to provide all the information about all the other transactions. The only thing that I need to prove to someone that that transaction is in this Merkle tree is this hash here, so 66C3, 5402, and the transaction data itself. And from that, you can merge it, you can hash it all together to generate the Merkle root. So this was in the original design of the Bitcoin blockchain. It's used for simplified payment verification so that you can have lightweight clients that can only download a tiny fraction of the blockchain and verify that a transaction has ended up in a blockchain. So that's the first step of some of the elements that are included in the block. So you've got the transactions here, you've got the Merkle tree. What we're going to do is take that Merkle tree and some other data, and we're going to put it into the block header. So in the block header, you've got the timestamp, you've got the previous block header hash. So there's another transaction to the left here, another block to the left here that you hash, and you put that result into there, and then you put in a nonce, and you put in the Merkle root transactions in this block. So you can see here, we've got E251 being included into this block. Just so that you can see what another representation that I really like of the blockchain, you can see you've got a block here. It's got the previous hash, nonce, Merkle root, and timestamp. You hash all of that. It goes into that hash of the previous block. Put in the Merkle root of all the transactions in this block, together with the timestamp and the nonce, and you go on and on. And that's the chaining element of the blockchain. And this is basically how it works in Bitcoin. Obviously, it's a little bit simplified, but that is the crux of how it works. So back to what we're doing with this block header. You take this whole block header and you hash it. Now, what you're trying to do is you're trying to play a game where you get the smallest number, trying to get a very small number by hashing it. In this case, we're aiming to get 0, 0, a hash that starts with 0, 0. So we did it once. We've got 66B1, so that's not good enough. What we'll do is we'll increment the nonce up to 47. The hash of this block header has updated, but it still doesn't start with 0, 0, so we haven't won yet. Increment it again, and as luck would have it, we've landed on 0, 0. So now this block has successfully been mined, and we can move on to the next block. So that's the proof of work element of Bitcoin and how that works. So to compare what Bitcoin does with XCredits. So once again, we have some block data, but in this case, we're actually keeping all of the block string. We have our timestamp, our nonce, and our transaction details in this block string. We also have in our block header a timestamp, which is just like Bitcoin, the previous block header, which is just like Bitcoin. But what we do with our Merkle root, rather than looking at the transactions in the current block, we look at the transactions prior to this block. So we keep a certain number, let's say 1,000, since the previous block in a Merkle tree. We don't have a Merkle tree for this block. We take that block string, so that's the difference there. With the nonce, we're moving the nonce for the block header into the block string. So it's going out of the block header, and then we take the hash of this block string and we put it into our block header. So there's a block string hash in the block header. Now the reason why we do this is because, and why we can do this, is because we will have micro blocks. There will be very few transactions per block in the system. So this is this string here is very low weight to communicate to people in the network. But the advantage of doing it this way is that we've made the block header deterministic. All of the changes that we've had to make in order to mine are now done at the nonce level. So once again, if we're doing proof of work, we take the hash of the block header, and then we're trying to get to 0,0 again here. So we'll update the nonce in the block string. We're going to 4.7, not ready yet. 4.8, we're successful. So it starts with a 0,0. So that's how we how we do mining on the XCredits blockchain. The reason why this is ASIC resistant is because the header is deterministic. So yes, you can communicate the header, you can tell all your peers, here is a summary of the block, and you can prove very easily that sufficient proof of work is done without having to communicate all the transaction data. But in order to mine the block, so if you're a miner, you have to communicate all of the data of all of the transactions that you're mining on to all of the CPUs that you're mining on. So that means that the problem stops being about how fast you can do hashing, and then it converts into one about how fast your networking is, how well connected you are to the internet, and how much RAM you have. So in that way, mining on the XCredits blockchain is much more analogous to the problem of validating the blockchain than Bitcoin is. So because you have to communicate the blockchain to all your nodes, you have to store it, you have to validate it for all the transactions, it's much, much more analogous to actually doing the work of the blockchain that you think the Bitcoin blockchain does. Like when you think of miners, you think of them checking transactions. The majority of proof of work that's done is not checking transactions. It's actually on taking a hash and adding another hash to it and then hashing that. And you keep on doing that and again and again. There is no validation that's being done on the majority of mining in the Bitcoin blockchain. XCredits changes this with ASIC-resistant block hard mining. Now, one other thing that is an innovation that we've had to come up with because of those microblocks. Let's say if you're a miner, you've just mined a block and you're getting some fees, 30 XCredits worth of fees. But it turns out that's not worth very much. XCredits, we're aiming to get our transactions down to like 1/10 of a cent per transaction. So that miner spent some proof of work mining that block. Yeah, it's only 1/10 of a cent, but they want to get rewarded for it. The problem is 1/10 of a cent is very tiny. And if you're doing the proof of work for one transaction, and you're getting the fees for one transaction, the fees to spend that one transaction will be the same as the amount of fees that you earned for earning that transaction. So like you've done 0.1 cent of proof of work, you get 0.1 cent of reward back, and now you want to spend your 0.1 cent and you have to like come up with another 0.1 cent of mining in order to spend it. So it doesn't really work out. The reward is too tiny, and so that means it's an unspendable transaction. What we do instead is we add a multiplier to our block. And the multiplier says, instead of getting that block reward, what we do instead is have in this case it's 4, so it's a 10 to the 4 probability, 1 in 10 to the 4 probability of being rewarded 10 to the 4 more fees. So it's a 1 in 10,000 chance of being rewarded that block, but if you do get rewarded that block by chance, then you get 10,000 times more fees. So let's say we're going down the line and there's more blocks being mined. Eventually, that block is pushed towards the central block, and then you have, it's the first central chain block that it's being pushed to. What you do is then you take the hash of this transaction and you hash it with the central chain block. And then if the hash has enough zeros in front of it, again, then the miner gets the reward. If not, they get nothing. So in that way, if it leads with 4 zeros, then boom, the miner gets a, in this case it would have been a $1 return, but it might be a $10 or $100 return. But if it has less than 4 zeros, then you get nothing. So in this way, you can incentivize people to keep on doing these tiny little bits of proof of work, but you don't have to worry about all these unspendable transactions in the blockchain. So at this point, the central chain block gets pushed to the shard, and then the miner that mined that block can start claiming that transaction on this blockchain. What happens when our side shards fill up? So we might start with like lots and lots of, maybe not that many shards. Let's say we have 4 shards, but we need more because lots of people are coming onto the network. So what we do is we indicate to the network through the central chain, once a transaction is pushed to the central chain, you have to split the addresses down the middle. So in this case, we've got shard 01. We split it up for all transactions downstream from this one. You have to have shard 010 and shard 011. So you notice that this one starts with the 01. This is starting with 01, and so is this one, but this one, the next one is 0, and this one is 1. So in this way, it prevents people from, it allows the chains to split in a coherent way without having double spends on one blockchain that you don't want. So you don't want to have people being able to spend the same transaction output on both of those shards. If you get a situation where you have someone who's mined a block where it's got transactions from addresses 011 and 010, you just have to discard that block, take those transactions and merge it back into the next step. Another feature, obviously, despite the fact that I kind of ratted on Lightning, I actually think that state channels are very, very useful. So like Lightning, you'll be able to make a time-like transaction and then off-chain with your partner, transact back and forth, and then eventually push your result back into the side shard. So that is the technical side of XCredits. Now I'm going to talk a little bit about like what we're going to use it for and how useful it could be. So I actually think that tokens are the real revolution of cryptocurrency. That's why Ethereum was so popular. Like people had all these ideas about how you might be able to represent other things on the blockchain. So you might be able to represent traditional money, put Australian dollars or US dollars onto the blockchain. You don't need to transact in Bitcoin or Ethereum or XCredits for every transaction. In fact, it might be very unstable. But if you're paying for the fees for the transaction in XCredits and it's like 1/10 of a cent and it goes up and down, you don't care if the 20 cents that lives on your phone to facilitate your transactions, goes to 100 or 150 transactions. It's nothing money to you. What you really care about is the tokenized dollars in your wallet. And so we can do this with XCredits. Other things that you can do, drop company stock onto the XCredits platform. You would be able to use tokenized Australian dollars to then buy Australian stock or maybe even foreign stock, as long as they're compliant. But this would allow companies to self-list onto a blockchain. And obviously reward schemes, they are ubiquitous, but actually pretty hard to get into if you want an electronically tracked reward scheme. If you're a small shop, you have to rely on paper cards that people stamp. with a low-cost reward scheme, blockchain-backed system with an open source client, you'll be able to do that efficiently and easily. On to the point about regulatory compliance. Obviously, all of the tokens would be able to do its AML and KYC by being able to co-sign for transactions. So if you're the Commonwealth Bank and you want to use XCredits as your accounting system for your tokenized Australian dollars, you're not necessarily leaving it up to the wild, wild west of cryptocurrency. You can still say, I want to be able to sign the address of the sender and receiver to validate that they're a real person that isn't a terrorist, so that we can comply with the law. A lot of people think that banks are out to get cryptocurrencies. I don't think that they are. And if you look at I'm not going to name names, but there are companies, banks, that have accepted illegal transactions, and they do so regularly. They like to push the envelope a little bit, most banks, but they usually like to stay compliant. So they have to have an AML KYC process. So that's definitely a focus for some of the tokens that we'll be putting onto the XCredits platform. And then there's privacy. I don't know how many of you actually have read this, probably no one, but we have a system called XBOT, and it's called XCredit style private off-chain transactions. And the idea of it is that you can tokenize, put tokens onto the Bitcoin blockchain and send transactions privately. We have a proof of concept on our XCredits GitHub repo, but we'll be transporting that proof of concept over to XCredits core as well. Our integration system, it's a TypeScript-based system. XCredits core is written in TypeScript, and so is the Express backend and the Angular front end. And so that means that it can work on a lot of home devices, on any web device, so any phone, any smart TV. Your device might be 1 million years old, but there's a good chance that it's still going to be able to work with XCredits. But the other thing that's a huge advantage of this is we are developing a progressive web app. So it looks like an app, it acts like an app, but it is actually a web page. And that means that you don't need Apple Store or Google Store or any of the other store listings in order to be active. So that reduces the ability of governments and particular payment providers to restrict you from being able to operate. But it's also open source. So if you wanted to take our system and replicate it and run your own server, your own version of it, you can go ahead and do that. The mining story is pretty awesome in my opinion. Because of all of the innovations that we've made, the aim is to get people mining on their regular hardware. It's actually, it's still not very cost efficient, but it isn't going to be orders of magnitude less efficient than a GPU miner like Bitcoin is, because you have on your laptop an SSD, a CPU, and a connection to the internet. You've got the things that matter when it comes to mining on the XCredits blockchain. It's resistant to centralization for that reason. If we can get more computers running it, that's better. And the other thing is, because we're running on the web and you're in the web sandbox, we're resistant to security issues. So you don't, imagine this, you're interested in crypto, you've got a private wallet on your computer, and you go and download some new coins mining platform. You are a massive security liability at that point. You've identified that you're interested in crypto by downloading this in the first place, and there's no way you're going to be able to audit that code. But if you're working in the web sandbox, if you're just mining in a web browser, you don't have to worry about that, because if they can get out of the web sandbox, they can get out of the web sandbox for anyone's computer in the world. So you have a lot more confidence by mining on XCredits in the browser than any other system. For the consumer journey, like I said, Progressive Web App works on anything. It provides you with the ability to set up a point of sale or to send and receive funds. And yeah, this is just a little bit of the consumer journey, come and buy your stuff, scan the point of sale, click the OK, and it's communicated to the network and the result is returned to the merchant. We have a great team, myself and 5 others at the moment. We have 3 other developers other than me, and actually one of them isn't listed here, so Hassan isn't up here. Yeah, great team, been working really hard so far this year. We also have some awesome advisors, most of whom have some sort of financial background, but also a couple of pretty experienced IT people in the middle there. Obviously, we've kicked some goals. We've developed our lazy web app platform that allowed us to do a lot of this stuff. We developed Send Zero, which is a proof of concept for our networking infrastructure. And we have released our white paper, currently working on our basic transaction functionality. And now we're trying to raise right now so that we can hire more people, really battle test our platform, and then hopefully get this out to people to start using it. A lot of people like to talk about this, so I thought I'd put in a slide. How we are going to operate our token model. We have 100 billion XCredits in the first year. 80 billion goes to the company, and 20 billion goes to straight mining. So there's a big mining incentive in that first year to get people into the network, start validating, and start adding security to the network. In that first year, we're going to push out lots and lots of tokens, probably at a very low cost. The reason why we're doing it this way, rather than just no pre-mine or 100% pre-mine, is because there are people who aren't allowed to purchase cryptocurrency. It's very hard for them to purchase cryptocurrency, so you need to be able to give them the ability to mine the cryptocurrency. But on the flip side, there are people who aren't able to mine and they want to get in. So this is actually a strategy for maximizing the initial distribution of the coin. From that point on, after that first year, it's going to be 1% mining reward, and XCredits will progressively sell down 10% of what's left. We're currently in a raise. If you have friends who like this idea, currently raising $3.6 million to build out the team and really get some partnerships going. And that's XCredits. Thanks a lot.
Thanks very much, James. There was a lot of technical terminology in the presentation, and as someone who's been in the industry full-time for 3 years now, I'm able to follow along with this kind of presentation, but I'm sure that with different levels of understanding in the room, there'll be various questions, but perhaps to clarify some aspects of how that works. So I might start if any of you are not familiar with the expression ASIC or ASIC resistant, for example, Bitcoin is now mined with very advanced custom hardware chips that are referred to as ASICs. They're designed purely to optimize to the Bitcoin algorithm. What it means is that the ordinary everyday person can't mine Bitcoin directly. It's just not possible. So what you're proposing is something that's more democratic, more available for people to mine with typical laptops, desktops, that kind of thing?
Exactly. The ASICs are not just GPUs. They're custom integrated circuits that are specifically for doing these hashing algorithms. So they design the chip from scratch to be able to only do this one thing, and that means it's like hundreds of orders of magnitude more efficient. So this system is actually more like trying to solve a general purpose computing problem. So you have memory and you have the CPU, and the CPU is acting on the memory and trying to solve some problem. So it's much more like the hardware that you might have in your phone or your laptop.
Okay, so with your block reward model of having a small chance of getting a much higher reward, it's like a bit of a lottery style approach that you're proposing. So does this mean that people will be better off in pools rather than trying to solo mine, like to share the higher chance of picking up one of those little jackpots?
So that's a great thing about this. We don't need pools if people are allowed to get a few bucks at a time. If you're on Bitcoin, I mean, you might be lucky enough to mine a Bitcoin with 10 graphics cards after half a year, but it's very unlikely. So if you are able to get every day a couple of bucks, you don't need to put all your trust in a mining pool. And that means it's a lot more democratic. Obviously, there are limits to what you can do with that. If you've got a limited internet connection, then you might be better off getting into a mining pool to mine the central chain, which doesn't have that memory hard aspect of it. But yeah, it is actually a lot better for home miners. You don't need the mining pool in order to generate revenue.
Okay, given where you are on your roadmap, you've architected quite a complex blockchain with the side shards and the central chain. It's on a level of complexity, like I've looked at protocols like Ardor, for example, with Ardor main chain and then child chains. There's some similarities, but some big differences as well. These kinds of complex protocols take several years of development and testing and proving that they're able to serve at scale. So you talked about the TPS limitations or transaction throughput limitations of other blockchains. After a number of years of development, we've seen the tech get to the point where I think EOS at 3,000 TPS is probably the fastest production chain. There's Red Belly blockchain that I think Data61, CSIRO are working on. They're saying they're up to about 10,000 TPS in testing, but yet to be proven commercially. Where is XCredits going to land in terms of performance based on your assessment so far?
Yep. So one of the things that a lot of people would see as a downside, but I see as an upside in terms of scaling, is that we don't have smart contracts. So we don't have to deal with the complexity of trying to ensure consistency between the shards when you have a smart contract that's trying to pull information from this address here and this address here and this address here. So in that perspective, in some ways it's complex, but beyond what I've just presented there's no more complexity to it. So it's actually quite a simple derivative from Bitcoin. Now, we don't have all of that implemented yet, but in terms of where we are relative to, say, Red Belly blockchain, we actually are working on a stylish and usable interface, which is actually quite a bit along, from what they are. Not to say anything bad, but they are still looking at the theory a lot, and we're actually thinking about the end user experience simultaneously.
They're focused on building a fast engine, and you're building a whole vehicle kind of approach, if you want to put it in that kind of analogy. Your web app and the ability to stream application services.
Yep, exactly. And the other side of it, and I don't know how far along they've come, but they were struggling with the economic model towards the end of last year as well. So so I don't want to say too much about the economic model because economics involves people. So making predictions about groups of people is very, very hard. But we have a proposed economic model that we believe can work. So we can take that proposed economic model, put it out into the wilderness, hope that it doesn't fall over, but if it does, we can go back to the drawing board after that. So we actually have something to work with on that front as well.
Okay. I've got just one more question of my own before I open up to the audience. I'm asking several, but one of the things in the presentation earlier on, you talked about the 1.7 billion unbanked in the world.
Yeah.
And then when you presented the means by which people can acquire tokens, they can mine them or they can buy them. Is there a third option? So, for example, for people that can't afford to buy them, that can't afford mining equipment, what's their option? Are you going to do any kind of airdrop or any sort of other distribution of the tokens?
Yep, so the way that I imagine XCredits being used, and I think actually every single blockchain in the world, is that the majority of transactions that you do won't actually be crypto to crypto. It'll be a fundamental system for exchanging other things. So if you're in sub-Saharan Africa, it's very unlikely that you're going to have 10 GPUs ready to go to mine XCredits. And it's also very unlikely that you're going to have the KYC necessary to buy off the exchanges when we start doing our rolling token sale. The thing about our system though is that you can get going on it with a very small amount of mining power. So if you've got a very basic laptop, you might be able to generate $1 worth of proof of work in a day. That would be enough to pay for the fees for, let's say, 1,000 transactions. Now that person who's generated that might be someone in a community that might be trusted. They might be, the local post office, or they might be a village elder or something like that, that is already responsible for doing things like managing money and resolving disputes. So this person can actually tokenize some of the deposits or the ability to resolve disputes onto the blockchain, and then people can start taking their very basic phones, and I don't know if many people know this, but a lot of people in the third world actually have very basic Android mobile phones. They can do things like scan QR codes. So they can go to that person, that trusted person, and start doing electronic transactions. And the advantage for that person and the shopkeeper is they don't have to carry cash. They can password protect their phone, and they can prevent being mugged and having to deal with all this cash that sometimes goes up and down in value a lot, but is also very unwieldy to deal with.